let's look at the assignment from the other day. So we have correlation versus causation. There's just a couple I wanted to go over with you. So remember, correlation is a relationship. But cause and effect is causation. One causes the other. So you can have a correlation without causation. Remember that correlation does not imply causation. Make sure that your slides are complete for Unit 7 and that you turn those in. Yeah, it's Unit 7. All right, so one of them I wanted to look at. Did y'all get this down? Anybody still writing? Cause and effect for causation, just a relationship for correlation. Number 17, a student with many absences and decreasing grades. So do the absences of the student cause decreasing grades? Think about the remote students. They're absent or they're remote, but they're not necessarily having decreasing grades. What really causes your grades to decrease? Not doing your work, exactly. So just the absences cause decreasing grades? No, it's more than that. There's other variables that cause decreasing grades. So this is just a relationship, not causation. Okay, let's look on the other side. So there's a few more correlation, causation. 4 and 5, it says put the following correlation coefficients in order from weakest to strongest. So something I want to remind you about is slide 8. Correlation coefficients show strength and direction. Right here at 0 is very weak. But if you go toward -1, correlation is stronger, and toward +1, it's stronger. So really with correlation, you're looking at how far away from 0 your correlation coefficient is, and that tells you the strength. So you ignore the negative. So right here, what would be the weakest? It's the one closest to 0. Yeah. Because that is your weakest. And then you go up from there. Well, I guess not up, but you go toward 1 or -1. So we've gotten that one. So it would be the next one. Yeah, 0.45. 45 hundredths. And then -54 hundredths. So it doesn't matter if you're going close to 1 or -1. It gets stronger as you get close to either 1 or -1. And then 87 hundredths. And then -98 hundredths. So this is the strongest. This is considered a strong negative correlation, which means it'll just go downhill, but in a straight line. The next set of problems is asking, is this correlation positive, negative, or none? So number 8 is what I wanted to look at. Your age versus the cost of insurance for your vehicle. Whenever kids turn 16, they start driving. Some of y'all are probably working on your permit right now, or maybe you've gotten your license. Whenever you're young, whenever you're right at 15, 16, let's say you were able to get it at 15 with a hardship, your insurance is going to be really high. But as you get older, your insurance goes down as you prove that you're a good driver. But being real new to driving, they charge you a lot. So if we think about it as a graph, this being age, our x-axis being age, go ahead and draw this. We're going to do just a quadrant 1. And y being our insurance costs. I'm just going to abbreviate with INS. So let's say we start out at 16. Our insurance is going to be really high. But then you get older, and it starts to decrease. I think it's right around 25 that it really decreases.
It decreases a little. If your driving record is good, it decreases a little bit when you turn 21.
Okay.
And then a little bit more when you're 25.
Okay, yeah. And then it levels out, right?
Yeah.
But just for, the first few years, it's definitely a negative correlation. It's going down. It will never go down to 0, but it'll continue to decrease. But if you have accidents or speeding tickets, then they're going to raise it up. And then 10, 11, and 12, circle the best correlation coefficient given the graph. So you're guessing what is the R value. So a way to determine that is look back at our slide 8. And this was where we were doing some estimations. Okay, whenever you finish this, turn it in.